Assalamu alaikum. Good evening, all. My name is Mohammed Al-Aish, and on behalf of the American Society of Mechanical Engineers, Eastern Saudi Arabia section, I would like to welcome you all to our December technical webinar. I would like to thank the Saudi Council of Engineers for their support, and I would also like to extend our thanks to our sponsors, ValvTechnologies. Today, as part of our technical webinar series, we have two presentations by ValvTechnologies. As always, we welcome all of your questions, so please feel free to type your questions at any time during the presentation. Our moderators will share the questions during the Q&A session. Please note that this meeting will be recorded and shared for knowledge sharing purposes. Our presenters' contact information will also be available in case you would like to direct a question to them privately. Stay tuned to the end, as we will be having a raffle ticket event for some of our lucky attendees. So please be sure to join in with your full name so we are able to contact you after the event. Without further ado, I would like to leave the floor to Mr. Yazan Al-Maani.
أخ يزن.
Yazan, you're on mute.
Just a second, I'll unmute you. Just. You should be able to unmute yourself, I think.
Can you hear me?
Yeah, loud and clear. We can hear you. Or I can hear you at least.
Okay, so Yazan can't unmute himself for some reason. This is David Birks, ValvTechnologies, Middle East and Africa. So John Furfy is going to be covering what you see on the screen on the agenda. He's going to talk about the definition of severe service. He'll explain some of the reasons of failures and show you some good examples in the oil and gas area of where valves fail. He will talk about zero leakage and how we can, take that to the field and maintain it over time. He'll go into some of the application details and case studies. So John has been with ValvTechnologies for just over 2 years, but he's an experienced professional with major OEMs over the last 35 years. He's been in the oil and gas business with valve manufacturers. He's worked out of Asia and also out of Italy, and he's based in Houston, Texas. So John, we'll hand it over to you.
Very good. Good evening, everyone. I hope that everyone can hear me and can see the screen with the introduction screen. Very good. Welcome. It's my pleasure to be here. You should be seeing the introduction of the agenda, where we're going to be talking about zero leakage and severe service applications, and give multiple examples, in particular on scraper traps and molecular sieve. We have many different applications that we use our valves for. So if you don't remember anything else from this presentation, remember this, that ValvTechnologies manufactures only metal-to-metal seated valves. We don't manufacture soft seated valves. We only manufacture valves that are used for severe service applications, 100% metal seated and 100% zero leakage, as defined by numerous specifications, which we will get into in just a moment. So when I talk about severe service applications or critical service applications, what exactly are we talking about? Well, if you're producing oil, gas, and water, oftentimes off the lateral line from the wellhead, you will have a lot of sand or abrasive material inside the pipe that ends up impacting the valves. You can also have highly corrosive surfaces. If you have any H2S present and it's wet, that makes sulfuric acid, which is very corrosive. If you have CO2 and water, you make carbonic acid. That can also corrode the valves, corrode the pipe, and then the scale inside the pipe ends up going down line and can produce black oxide and other very severe service types of applications. Also, when you get into very high temperatures, over 800 degrees C or down to cryogenic for liquefaction of methane gas down to -196, when you start getting into very high pressure applications like your API 6A 15,000 PSI or 15K valves. Also thermal shocks, when valves go through low temperatures up to high temperatures down to low temperatures with severe thermal fluctuations within a short period of time, say a minute or 2 minutes, this can make for very severe applications. Also, let's not forget safety. Safety is always number one. It is here, and I know that it is in Kingdom and with everyone attending today. So when you have lethal service where you have like H2S present, as little as 500 parts per million can kill you. Also, we're all concerned about preserving our environment, and fugitive emissions leakage through a valve can be a great contributor to the greenhouse gases, which lead to global warming. Also, economic impacts that you can get from utilizing valves in severe service. If the valves have downtime, you lose your efficiency, you lose your production, you have labor costs, severe temperature swings, and of course, high cycle. So here's a couple of examples of severe service applications that you may be able to relate to. Corrosion, hydrogen embrittlement, abrasion, erosion. You end up getting weld slag splatter contamination, which is going down line and impacts the valves every time that you open and close them. Black oxide, I know, can be very prevalent in many areas of the world and can be a real challenge for production. Let's take a look at a typical type of severe service application, which is called erosion corrosion. Basically what it is that if you have a material and you have a corrosive environment, the internals of the valve will start to rust and to corrode. Then if coupled with that, you have abrasive service. The abrasive service continues to erode away the rust that is inside the valves and makes the corrosion be exposed to new metal all of the time. Over a period of time, this can greatly impact the valve, where you have corrosion and erosion happening at the same time, and can make for severe pitting in the valve. So when you are opening and closing your valves, there's a number of areas of what I'll call high impact. These areas are depicted in the picture right here. You can see this valve is going in from the open position to the closed position. And as you do that, you impact your upstream seat and then your downstream seats. When the valve is closed, if you have any kind of debris in between the seats, you can scratch the ball and the seats themselves. And this can lead to leakage. And our experience is that once leakage starts in a valve, whether it's at the factory during final acceptance test, FAT, or if it's in the field, the valve does not heal itself and the leakage will only get worse. These are a number of different specifications and different leak rates that are very, very common in oil and gas industry. So the majority of valves work very, very well. in the correct service. However, when you start taking valves and you start taking valves that are not designed for severe service applications and you put them into severe service applications, you can get debris like you can see right here. This is a typical seat for a trunnion mounted ball valve. This is the ball right here. You can see that the seat has a plastic insert. More than likely that's a grade of nylon. And you also have debris. You have a piston effect on the seat, and you can get debris buildup back behind the seat. Even on metal-to-metal seated trunnion-mounted ball valves, they typically rely on elastomeric seals or thermoplastics to seal. This is black oxide right here, something that probably many of you have experience with. This is the type of debris that I'm talking about that can get back up, sand coated with oil and grease, can get back up behind the valves. Also, elastomeric seals, when they get into higher thermal cycling, you can see here that this is a Viton seal, and you can see how much it deforms as the temperature goes up to 150 degrees C. These are thermoplastic lip seals that, given the right working conditions, work outstandingly well as Chevron V packing right here. But again, when you start having severe service applications, all of these types of seals can be damaged. As an example of that, let's take a look at when you're producing a pipeline and you're welding the pipe joints together. You get weld splatter that goes on the ID, on the inside of the pipe. Here is what weld splatter looks like right here. You can see it almost looks like little BBs, small little round particles of the weld slag that gets inside the pipes. And then when you start to flow or do your hydrostatic testing, this material goes down and gets embedded into the soft-seated valve, which, as you can see right here, weld beads in the valve during startup. Here's a very good picture right here. You can see the little bits of weld bead that are in there. And then consequently, what happens is that as you open and close your valve, you end up scratching the ball itself, as you can see down here. Here's a picture of a valve that has debris completely inside of it. And when we took it apart, you can see that the valve will not function properly with that amount of debris inside of it. Here's what a typical brand new ball looks like. Actually, those balls look very beautiful to me. They are very nice. They're LF2 with 1 mil of electroless nickel plating. But what happens when you have that weld bead and other types of debris inside the valve? As you open and close that valve, you have debris stuck between your seats and your ball, and it will scratch the balls. And as the balls scratch, they start to leak. As they leak, then more erosion and corrosion starts to affect the valve and increase the rate of leakage. This is a table that shows you some typical oil and gas and industry standards to measure leak rate and acceptability of a valve at the factory. How much can it leak at the factory and still be okay? Here's a couple of very typical examples. Your ISO 5208 is referenced in API 6D, and you can see that it has acceptable leak rates for metal-to-metal seated valves. The leak rate that we always use is leak rate A on our metal-to-metal seated valves, which is exactly zero leakage. Again, to show you in a graphic form, here's a number of different industry standards for when manufacturers are shipping their valves from the factory. They must meet these standards. If your standard is FCI 70.2, you can see that the leak rates on a 16-inch valve can become quite severe. ValvTechnologies leak rate is always the same. We utilize ISO 5208 as referenced by API 6D, and we utilize leak rate A. Here's some of the times and pressures that are called out. We manufacture our valves up to 42-inch in diameter. Here's an example of a test which has been third-party witnessed by Bureau Veritas. In this test, a major oil company in Latin America, a national oil company in Latin America, came up with a procedure to test valves durability in severe service application. They had us fill and make the valve full of 40% sand and 60% Vaseline. We packed the valve with that, and then we started performing cycle testing on it while the valve was under pressure. First, we did 10 cycles to see if it would hold. It held fine, and then we tested it. Then we did 200 cycles with no differential pressure, and then cleaned the valve and tested it again with nitrogen gas. The valve held both the shell test and the seat test with zero leakage. This certificate is available for anybody that would be interested. Here are some of ValvTechnologies valves that have been in service in different severe service applications for a period of time. You can see this valve right here was used as a HIPS valve. It's an API 6A valve, and it was in service for 12 years. After disassembly, after a shutdown, the inside of the valve still looks perfect. Here's one of our balls that has been also in a 6A HIPS service for 14 years. And although there's a lot of debris on the valve has special construction and is coated with TCC, tungsten carbide coating, or chrome carbide coating, and the seating area is still beautiful. Although there's slight discoloration on this valve, it's another 6A valve. It was in service for 14 years and has no leakage at all. Again, more seats. This is in 8 years in molecular service. The seat has tungsten carbide coating on it, which makes it impervious to the weld slag, the weld beads. Here's a ball inside the valve when we first took the closure off. Again, another valve. This one was in coker service in a refinery, very high temperature, for 8 years with no consequences at all. This is one that was in service up in Canada for 8 years, and no problems with it at all. Here's another test report. This again is third-party witnessed at our facility. Our main facility is in Houston, Texas, and I extend an invitation to anyone, whenever everyone can start traveling again. If you happen to be in Houston, it'd be our pleasure to have you visit us at our facility, and we can show you firsthand. So in this test right here, we had a 30-inch, 300-pound class. Remember, I said that our valves go all the way up through 42-inch in diameter. This is in a coker application in a refinery. We had third-party inspection. After 4 years of service, we took the valve out of service. You can see the valve right here. This is a schematic of the valve. And you can see that we performed testing with the acceptance criteria of ISO 5208 leak rate A. With nitrogen testing at low pressure, 20 psi after 4 years of coker service, the valve still is bubble tight, zero leakage. We then increased the pressure to 80 psi. The valve held just fine. Those results you probably can't see it, but again, we'd be happy to provide you with a copy of this. You can see the third-party witnessing and that there was zero leakage. We then did a high-pressure seat test on it at 790 psi. Again, the valve held perfectly. How is it that we're able to manufacture valves? What makes our valve unique in terms of being able to handle severe service? Well, we typically do not use elastomeric or thermoplastic seals in our valves. You can see right here, this is one of the processes that we specialize in. It has taken us 20 years to perfect this. We have 4 HVOF booths. HVOF stands for high velocity oxy fuel, and it's how we coat our balls and seats and inside of the valves, inside of the balls with tungsten carbide or chrome carbide coating. The HVOC, high velocity oxy fuel, is applied at very high temperatures. You can see here over 3,000 degrees C. That's greater than 6,000 degree F. That's how hot the flame is right there. The 4 booths that we have and all TCC coating that we do is proprietary to ValvTechnology, and we do it all in-house. The application, the grinding, and the lapping of the balls and seats. So it also is applied at an extremely high velocity. You can see here, it's almost applied at 5,000 miles per hour. That's incredibly fast. That's the equivalent of if you're like me, I understand Mach 1 is when a jet airplane is going so fast that it breaks the sound barrier. Well, we're 6 times that. What we do is we apply first the ultra high flame HVOF, but without any tungsten carbide and without any chrome carbides being applied to the ball. We simply heat the ball up to the right temperature so that the molecules will expand. The TCC coating, tungsten carbide or chrome carbide coating, is embedded in the ball. The adhesion strength that we have on our balls is greater than 14,000 psi. That's tested by taking a mandrel and gluing it to the tungsten carbide, and we do a pull test on it to see if we can get the tungsten carbide to delaminate from the ball. The highest strength glue that there is and the highest pull that you can give it is about 14,000 psi. So we do routine checking of the bondage and the adhesion strength of our valves for the tungsten carbide. This is very important because what you don't want to have happen is in the field to have the tungsten carbide start to delaminate. Tungsten carbide and chrome carbide is exceptionally hard and exceptionally durable. It is upwards of 70 to 72 on the Rockwell C scale. Another important property of the valve, in addition to the adhesion and the hardness, is the porosity. If you have a high porosity, which means you probably do not have an adequate lapping process that you're using, you can get delamination and high friction. Our porosity is less than 0.5%, and from the measurements that we've taken from other industries and other manufacturers, it's typically greater than 3%. So you can see right here that we have a very wide seating area between our ball and our seats. Both the ball right here and the entire seating area and the entire ball area is tungsten carbide coated. This seating area right here, we have constant contact between the ball and the upstream and the downstream seat. We accomplish that through what's known as live loading. You can see this is a valve that's come back to the factory where we're doing a case study with an end user. This one's from a user in Kazakhstan, a major oil company who we cooperate with and we work together with to solve some of their production problems on molecular sieve applications. Right here you have a Belleville spring, which we utilize both in the stem journal packing as well as the seating area to have what we call live loaded seats. You can see that the seat right here with the tungsten carbide coating is in perfect condition. Also with the ball, there's a slight amount of black oil on here, but no scratching of the ball at all. Interestingly enough, you can actually see, if you look, there's an indentation here of the oil where you can see the contact area between the ball and the seat. And then you can see that as that ball opens, it kind of smears the oil a little bit as it goes into the open position. In the open position, we still maintain full contact between the ball and the seat. And you can see that evident right here where there's a slight amount of residue left over on the ball of oil. What are some of the things that maybe you need to be aware of is that all tungsten carbide coating and chrome carbide coating is not created equal. Many end users, when you specify metal-to-metal seated valves, will put tungsten carbide coating on the ball and only a small strip of the ball and then on the seating area of the seat. And that way, when the valve is in the closed position, they can honestly say that the valve is metal-to-metal seated. We don't believe that thin band tungsten carbide is adequate to give you long field life in the types of severe services that our valves operate on a routine basis. Another issue that your valves can have is what's known as delamination. You can see here that the tungsten carbide looks very, very good, but it's delaminated around the seat and it's delaminated around the ball. So that valve will leak. ValvTechnologies manufactures 3 basic valves. One is called our V series. This is a seat-supported valve, and is typically used in slurry pipelines, as well as scraper trap receivers, launchers, many different applications. It does not utilize any thermoplastics or elastomeric seals. We also manufacture a Truntech. This valve is what we use for our API valves all the way up through 15,000 PSI and 42-inch in diameter. And then this is our NexTech valve. The NexTech valve comes off the shelf, ready to put into services of upwards of 800 degrees C or 1500 degrees Fahrenheit. Applications typical for this valve would be superheated steam applications for steam injection, steam floods, or perhaps power plants where you're doing a boiler feed. ValvTechnologies has a number of core competencies in-house. Here are 2 of our HVOF booths that we apply the tungsten carbide and chrome carbide, as you can see right here. Also, we specialize in MIG and TIG welding. MIG welding is metal inert gas. TIG welding is called tungsten inert gas. We have 5 robotic booths. You can see run right here where the operator is applying Inconel 625. Here's some balls that have had Inconel 625 applied to them. They'll then be machined, and then on top of the Inconel 625, we will apply our tungsten carbide. For cladding purposes, we can do cladding of either only the dynamic and static sealing areas, such as the seat pockets, stem and trunnion journals, or we can do all wetted parts. This can be a good economic solution to give you the corrosion resistance that you're looking for and have a valve that is more economical. This is our V series valve. You can see right here it has a number of Belleville washers on the bonnet area. It is a 1/4 turn valve. It's live loaded. It has 0 leakage. It's rated up to 1500 degrees Fahrenheit, or about 816 degrees Celsius. It does not utilize any thermoplastics or elastomeric seals. It is bidirectional and double block and bleed. Meets all industry standards for fire safe, NACE for H2S service. Also meets all the industry standards for fugitive emissions, as all of our valves do. And because of the low porosity that we have on the contact between the tungsten carbide on the ball and seating areas, we're able to open and close our valves very, very quickly. All of our valves also are SIL 3 and SIL 4 certified. You can see this is a cutaway of the V series right here. As I said, it's bidirectional, double block and bleed. Here's a depiction of our ball and seat for the high pressure side of the valve. This is a self-relieving seat, so pressure comes from the upstream side, and the upstream seat is pushed into the ball. So we have constant contact between the ball and the seats. Here is the Belleville Washer right here, which acts as a very powerful spring. That Inconel Belleville Washer is made out of Inconel 718. Again, here is a depiction of the V series. This is your high pressure side. You can see the Belleville Washer, and it's loading this seat onto the ball. On the downstream side, it's very unique. We do not have a seat insert, but we have an integral closure and seat, which makes for outstanding field performance. So when we assemble the valve, this is a picture of the Belleville Washer made out of Inconel 718. It's an extremely strong, extremely durable spring that we utilize, and it has upwards of 155 PSI tensile strength, which is very, very high. For instance, if it was made out of 316 stainless steel, it'd be somewhere about 35,000 PSI. So it's very, very strong, and you can see when we load it, it puts a load on the ball and the seats, and this is kept in constant tension. We have always complete radial and axial alignment of our ball. We hold very, very tight tolerances for all of our valves. And you can see even in the reverse flow, we have bubble tight leakage. If you ever were to have any kind of leakage up front over a number of years of service, that ball is being pushed by the Belleville Washer, and the HP, the high pressure coming in from the upstream side, pushes that ball into that downstream seat. We have that contact area right here between the ball and the seat, where you have constant contact of the TCC, tungsten carbide coating, or chrome carbide coating. This is an integral downstream seat and gives us zero leakage. You can also see at the top here, these red discs are Belleville washers, which are stacked and then torqued down to the proper torque. We maintain constant pressure on our packing, so we have no leakage up through the stem bonnet area. And again, our valves have been tested routinely and pass all fugitive emission standards in the industry. This is a typical schematic of a production field. You'd have your wellheads out here with lateral lines coming in to the production manifold. The production manifold either produces to the main production header, which goes to your production separator, or through the production test. The test separator allows you to manipulate the valves here, opening and closing them, so that you can measure how much production you're getting from any individual well. So from the separator, you have your gas, which is vented off of the top of the separator. Oil comes off the middle of the separator, and it's floating on top of the water. The water is drained from the bottom of the separator. This is a continuous process, and the water typically is treated and then injected back into the ground. The gas, if you're producing high gas content, oftentimes you'll have a molecular sieve to start cleaning up your gas. The first thing that you want to do is to remove any water from the gas. If you have any H2S in the gas with water and methane, you're going to have issues because that produces sulfuric acid. After production, typically you will have a pig launcher that will take and a pipeline that will produce and move your high pressure gas down into perhaps a liquefaction LNG facility. And then for the oil, it will be sent downstream to storage tanks or onto tankers. Application that can be very severe service for any valve is scraper traps and scraper launchers, in particular your receiver barrels and your main control valves right here, your main isolation valves. When that valve is closed and this valve is closed, you're able to vent the barrel and open the closure and take out your scraper. You can see a slurry pipeline right here where we have different valves from ValvTechnology with a hydraulic rotary vane actuator. Typically, we are utilizing our valves in high slurry applications for pipeline. A good example of that would be a pig launcher right here. This is your scraper receiver. You have a trunnion mounted ball valve right here with a spring return pneumatic actuator. This is one of the scrapers that is sent down through the pipeline. Its purpose is to push any debris or condensate that might be in that line down where you can take it out of the scraper trap. You can see here black oxide. Here's a pig receiver that's been opened. It is full of black oxide. That black oxide right there will get all embedded into your scraper trap and will be embedded in your main closure valve right here. You can see here a pig receiver that's been opened, and it has a lot of black oxide mixed with high viscosity oil. When black powder or black oxide is a result of oil and gas condensate mixing with sand, and then the rust, which is and scale, which is forming inside of the pipeline, especially if you have any amount of water that can condense inside the pipeline. That water mixes with the oxygen, the hydrogen sulfide, and the CO2, and it forms that black oxide. That black oxide is very, very abrasive. So again, here are some examples of the black oxide and different receivers, scrapers coming out. So that's what is filling up your valve right there. and which is oftentimes leading to valve failures in these critical applications. So we recommend that you always use a full open through conduit valve that is the same ID as the pipe, so that you have smooth transition of the scraper into the scraper trap and through your valves. We do not recommend that you use soft seated valves. We recommend that you would always use a metal to metal seated valve that can have long field life. Here's an example of a number of our V-series valves that we were just talking about with rotary vane hydraulic actuators. You can put any type of actuator on our valves, pneumatic, hydraulic, or oil. This is a picture of our valve, like you can see in the picture right here. This is a 24-inch, 600-pound pig launcher and receiver. It is a double block and bleed valve. Here's some details of the seat design. Again, this is a self-relieving seat, which is pressurized and pushes into the ball due to the upstream pressure. We've done a lot of case studies and like to work hand in hand to solve problems with our customers, who we greatly value. This is a case study that we did in the Middle East with a very major producer, major oil company, national oil company. This is a 36-inch valve, 300-pound V-series right here. Again, these valves are made up through 42-inch in diameter. These are seat supported, metal to metal seated. This valve was put into service for 18 months of operation, as you can see right here, and then was taken out and was tested. It was held on test for 30 minutes. This is an actual picture of the gauge on the where it's being tested, and it has zero leakage. Why is zero leakage so important? Well, if you don't have zero leakage, then over a period of time, your valves will cost more and more and will give you less and less efficiency in your field. You can see here that this is a comparison of end user that we did a case study with. This is 3 pieces of an 18-inch, 2,500-pound class. This is for pig receivers. You can see initially our valve was slightly more expensive than our competitors. Our valve is the blue line. Our valve went for 4 years with absolutely no problems at all, whereas the competitor's valve needed maintenance and replacement every single year. Due to that maintenance and repair and the leakage, you have much less efficiency, meaning that you are not producing the maximum amount of oil and gas that you would like to be. You have labor costs, you have downtime, and you have to have additional shutdowns in order to replace these valves. So over time, your total cost of ownership for a valve that works versus a soft-seated valve that does not work and has to have a lot of field maintenance and outages is incredible. You can see here that our valve, after 12 years of service, cost less than half of the amount of our competitor's valve, what this end user was previously using. Another application for our valves that is very arduous, difficult service is called molecular sieve. This is an overview of your dehydration tanks right here and your gas heater. In a molecular sieve application, it's a dehydration unit, and they utilize each of these drums here, switching from one to the next drum, passing the methane gas through here. The objective is to remove any water. Again, you want to remove the water because if you have any H2S in your production, the water and the H2S will form carbonic acid and will give you a corrosive environment. You want to knock that H2S out and the water out as quickly as you can. So the switching from one drum to another gives you high thermal cycling. There's many valves that are manipulating these drums here. Let's take a look at that. Here's what's really going on. You have each of one of the valves sees high thermal cycling. You have 3 drums right here. The first drum has the flow of the wet methane gas coming through it, and it's passing through the drum, which is full of zeolite. Zeolite is a desiccant which absorbs the water. over a period of time, that zeolite becomes saturated with water. So you have to manipulate the valves and change your production from one drum to the next drum. This drum right here is being dried. You can see your heater here is feeding high temperature gas through the zeolite and drying that zeolite so that it can be producing again. After it passes through, the drum needs to cool for a period of time. So you're continuously switching from one drum to the next drum by manipulation of the feed and exit quarter turn ball valves that are right here. This is an area of very arduous, severe service. So you can see here that this is an actual case study. Again, where an end user, a major end user in Kazakhstan, was having a lot of problems with the valves that they were using on this molecular sieve application. The zeolite was getting all up inside the valve, and it caused galling and deformation of the stem and scratching of the seat. Also, you have a bolted bonnet design on this valve that has a different coefficient of expansion than the body. So when the temperature swing happens and the gas passes through this valve, you get severe temperature swings in about 2 minutes time. So this major oil company came to us after talking to many other end users around the world, and they ordered 15 pieces of 8-inch through 16-inch, 600-pound class through 900-pound class valves. Here's some of those valves right here in our factory. These were made of solid Inconel with Inconel 718 trim on the inside because they had very severe H2S service. They had 17 to 21, 22% H2S and a lot of sand going through the valves. Downstream of the separator, the gas was passing through these valves, so they put our valves in service. And what they told us was that every time that the previous valves were in service, that they would only last between 1 and 90 days. And every time that the valves would leak, it would end up costing them about $10 to $15 million of lost production. How can that be? Well, when you shut in the molecular sieve, you're shutting in your separator because the gas has nowhere to vent to anymore. When you shut in your separator, you shut in your production manifold, and hence you're shutting in all of your production wells for a portion of the field is being serviced by that separator and manifold. Again, what makes the molecular sieve application so arduous and so difficult is that it utilizes zeolite. You can see a picture of it right here. There's rather large balls that are in there. They have a consistency that is, they're very porous, but they're very, very hard as well. And they produce a zeolite dust as the methane gas is passing through the molecular sieve application. The balls bump into each other and produce this gas. So this end user that we were working with was having significant downtime, and leakage to atmosphere with the 20% H2S, which also made it very, very lethal. That 17 to 20% H2S you can see here. So we went ahead and we put our valves in service, our V series right here, and they have outages every 2 years. You can see again that the valve was made of Inconel body, Inconel 825, and the internals were Inconel 718. Tungsten carbide coated balls, tungsten carbide coated seats. The valves worked perfectly and lasted through the entire shutdown cycle of 2 years. The valves were taken out of cycle and sent back to the factory where our customer came to our factory. This is the finding, an excerpt from our joint case study that we did with our end user. This is the actual valve with the serial number and tag number. After disassembly of the valve, we saw that although there was slight discoloration because of the high temperature swings, there's no damage or delamination of the ball tungsten carbide on the seats or the ball. The valve was still working perfectly well. Here's an example from up in Canada of a 3-inch 900-pound valve, one of our V series that was put in service for severe service applications. You can see here that our valve would last 8 years with absolutely zero maintenance on it, and would have taken out of line. It would be inspected Some of the parts the valve would be repaired for whatever needed to happen, and then it would go for another 7 to 8 years. Our competitors' valves were routinely having to be taken out of line. And you can see here, after the initial 8 years of service, our valve cost less than 5% of the life cycle cost of the repair cost, initial cost of the valve, maintenance, downtime, efficiency. If your molecular sieve unit is leaking, then you are not running at full efficiency and you will not be producing as much gas as you could be. If it leaks to atmosphere and has H2S, then you're in a lethal service. Our valves are also used in a lot of other applications in oil and gas. These are our valves in a produced water injection, where we have our water gas, and also used in what's known as WAG, water and gas, where they alternate enhanced oil recovery. You're doing what's called a water flood, where you're injecting water and then you switch and then you start to inject CO2 and then you inject water again. This pushes the CO2, which is wet, forming carbonic acid, and that helps to scrub the formation and give you higher production. Another area, as we mentioned earlier, was on production manifolds, where you are producing from a well, like you can see right here, where it's going either to the test header or it's going to the production header. This is a major oil company located in the Middle East, where they were using our valves for their production headers. They had very high temperatures swings, and they had a lot of scale and sand that they were producing, as well as H2S and CO. And they had a unique way of on the manifold of switching. They were able to use one double acting actuator right here to drive the two valves, like you can see right here on the manifold. So every time that actuator stroked, it would open the one valve and close the other. So anytime you had to do a production test through your production test header to see how an individual well was producing, all you had to do was stroke this actuator one time. It would open and close inversely each one of the valves. That's a very good idea, I think. Also, oftentimes you get into very severe service where you don't want to have downtime. And what we recommend there, API 6D talks about different types of valves that are bidirectional, double isolation, double block and bleed, and double isolation and bleed. The more stringent of any of those is the double isolation and bleed. We recommend there using a twin ball. That will give you outstanding durability of the valves, and we manufacture these. Here's another test from a major oil company in Latin America who has a lot of production offshore, where they are utilizing FPSOs to produce their oil and gas. They purchased from us quite a number of 8-inch 2,500 pound class for their header manifolds. You can see the valves at the factory here, and you can see them actually installed. After the valve was in service for a period of time, we took the valves out and we did a test to the valves. Again, we did a very low pressure test at 10 psi gas. The valves held bubble tight. Low pressure, 80 psi. The valves held bubble tight. And then a high pressure test at 6,000, almost 6,800 psi. We routinely give high warranties for our valves. And in this case, we had a 4-year warranty. And the valves held and produced very, very well. You can see again that this was third-party witness. We're happy to share this information at any time. This documents the actual leakage or lack of leakage on our valves when they had been tested. I said earlier that our valves are SIL certified to SIL 3 and SIL 4, all the way up to 42 inch in diameter, 2,500 pound class, and up to API 6A 20,000 pound class. Maintain all certifications, 6A, 6D, ISO. This is our fugitive emissions to your ISO 15848. certification that we pass. Again, you do not want any leakage to atmosphere or fugitive emissions, especially if you have H2S. 500 parts per million can kill you and is considered to be very lethal service. Also, API has a fugitive emissions test called API 641. You can see our valve being tested here in our test lab, where they do cycle testing and thermal cycling of the valve. We passed 100% and have a certificate from API who witnessed the test. Fire tested, fire safe. This is a 7 1/16 API 10K valve. You can see how it's nice and painted before the test, and then the valve has been burned, so it has discoloration. This is just a quick summary of a lot of the certifications that we have. One of them that we're proud about also is our ASME N stamp. That means that we also service the nuclear industry, which has extremely high quality standards. So we maintain our N stamp. ValvTechnologies was founded back in 1987 by Mr. Kevin Hunt, who is still our president and of the company right now. This shows you a number of different types of switching valves, and we're happy to talk about other applications that we utilize in downstream services, such as hydrocarbon services, coker valves. This gives you an idea of where our main manufacturing facilities are. Our main manufacturing facility is here in Houston, Texas. We also have a manufacturing facility in Chennai, in India, and numerous repair facilities around the world, a major service area and manufacturing facility in the UK, and in China, servicing the Chinese market. These are just some pictures, and it's our ambition going forward. We are currently in discussions with a number of companies that we're looking at partnering with, where we would very much like to be able to come in to give our support to in Kingdom with valve manufacturing and valve repair. As I said earlier, our valves go into many different applications, and we have a very large service department. And hopefully I haven't gone too long. And with that, I'm going to...
So John, thank you. Back to ASME. I see there's a lot of questions. John, to ask those questions, plus our Director of Engineering is online.
John, if you go to the chat section, you will find the questions which have come up from the audience.
Okay, just to clarify, would you rather we go to the next presentation or go with the Q&A session now first?
We are done.
It seems to be an echo. Can we stop the echo somehow?
Okay, is it clear now?
Yep.
Okay. Would you guys prefer to have the Q&A session now or after the second presentation?
Probably now would be best, so that we can do it with whatever questions would be asked on the information that I've just presented. I'd be happy to do my best to answer any questions that anyone may have.
Okay.
There is no second presentation. John just did it. So.
Oh, all right. Okay. I do have a list of questions that my moderators have shared with me. So if you would allow me. The first question says, they say even NASA had failures. Can you share any failure and how it was mitigated by ValvTechnologies that you've experienced?
I'm very sorry. I could not hear the first part of the question. It's something about...
Basically, the person who asked the question says that even NASA has failures. Can you share with us any examples of failures that you've solved and mitigated throughout your years of experience?
Yeah, absolutely. The case studies that we just presented are real case studies that we did in conjunction with the end users. And we've done many case studies around the world. We're happy to share that information. We have had, obviously, instances where our valves have failed. Every valve will have a failure point. I think what makes the difference between the two is that with any failures, if properly analyzed, and if you get to a root cause of what that failure mode is, you should be able to come up with the failure mode. It may be due to corrosion. For instance, in seat pockets of all valves, if it's carbon, I was just saying that any valve over a period of time will have leakage or can have a failure. We have definitely had field failures where our valve is not Superman and 100% bulletproof. The idea is to start on severe applications is to start engineering out all of the root causes that are making your valve fail. So the example I gave was if you have a corrosive environment or any water in the valves, if you don't put an Inconel 625 cladding in the seat pocket, you will very quickly develop in that sealing area pitting. That pitting will lead to leakage around the seat and failure of the valve. If you have very abrasive service and you're utilizing a soft-seated valve, that valve will not last very long. So what we strive to do is to work hand in hand with our customers to analyze and find out, be kind of like the valve doctor, if you will, work together to find a valve that will work and last and increase your efficiency. It's all about running your production and not having to shut down because of a valve failure in between scheduled shutdowns. That's in fact in the Middle East where I showed the one case study that we did jointly with the end user for this 36-inch pig trap receiver. My understanding is that they were having a lot of failures on those valves due to the black oxide. The black oxide was damaging the standard soft-seated valves that they were using in the pig traps, and they put ours in for 18 months. And again, when we took it out of 18 months, the valve was still bubble tight. The issue is that if you have valves that have an allowable leak rate at the factory, and to make the valve acceptable, the valve will already be leaking when you put it in line. And this leakage will just become more aggravated the more lethal and the more severe service that it's in.
Okay, we have another question that says, can high performance valves be utilized on throttling applications?
Generally speaking, yes. We do not recommend our valves for throttling applications, our ball valves for throttling applications. Our ball valves, or any ball valve is designed to be in the full open or the full closed position. In fact, this is one of the failure modes that many ball valves have, is even during startup and commissioning when you're doing hydrostatic testing of your pipeline, you have those weld beads and debris. And then if you leave your valve in that half open position, when you start to flood and produce and push that water out after the hydrostatic testing, you will bombard the upstream and the downstream seat with particles. Why would you have the valve in the quarter turn open position? Well, if you leave the valve in the full closed position, you typically hydrostatically test your pipe at 1.5 times the rated pressure, yet the seat is only rated to 1.1 times the pressure. So if you have your valve in the closed position and you overpressurize it, you can damage especially a soft-seated valve. This is why we recommend not utilizing soft-seated valves in severe service conditions, but to use a metal-seated valve and to specify leak rate A. ValvTechnologies is not the only manufacturer in the world that can produce leak rate A valves, but there's a small amount, not many valve manufacturers can say that their valves meet 5208 leak rate A. Our valves do that, and we put a warranty 4 to 5 years on our valves, and we have service teams, and it's our ambition to have a service center in Saudi Arabia, and then with any luck, hopefully we can move from there to full manufacturing of our valves, perhaps initially doing hydrostatic testing, gas testing, actuation mounting, which is called value added initially, and then if we can cooperate and work together to solve problems, and if our customers in Saudi Arabia, in Kingdom, see the value of our valves, we believe it would be best for us to serve you by having local content and local repair facilities. So we can quickly, when we have valves that are changed out, do any repairs to the valves and get them back in service during the scheduled shutdown.
Okay, before I go to the next question, thank you very much for the very detailed explanation. That was spot on. Our next question is regarding kicker lines. So the question goes, do you have applications for kicker lines where the valves may remain in one position for a year or so with a lot of solids accumulating in the line?
Sure. Our valves are used as kicker valves. We do typically recommend metal-to-metal seated valves. That's an application that a lot of end users utilize metal-to-metal seated plug valves, which actually is a very good valve. They are not typically used in what I would call extreme severe service. The blowdown valves will, as you said, be in a static position, static closed position. But when you have to get in and do maintenance, you need to be able to bleed the pipeline to relieve any differential pressure. That's when you would open up the kicker valve or open up the kicker valve to supply pressure back behind the scraper launcher to propel the scraper down the line. Our valves are typically used for this application as well, because as you said, this valve, although seldom used, when you need it to work, you need it to work 100%. You need to have a valve of very high reliability, and our valves with metal-to-metal seated, live loaded at all times, is an outstanding valve and works very, very good. Again, this is an application that we would look forward to cooperating in Kingdom with, and would be happy to give extended warranties, which we feel very comfortable doing because of the applications and the robustness of our valves.
All right, I have a few more questions, but how are you with time? Would you rather we stop here, or do you want us to keep going on?
For me, I'm happy to answer as many questions as people are interested. I'm happy to discuss any aspect of our business. Okay,
because it's due to the time difference, we don't want to take too much of your time.
No, I don't want to take too much of your time.
Okay.
I'm here to answer your questions. Thank you.
Muhammad, excuse me, Muhammad. There are some missed questions, I think, at the beginning from Mr. Saad Shiha. He mentioned that as end user, how to verify HVOF procedure, knowing that every vendor has his own.
Okay, there you have it. That's the next question.
Yes.
We've been going at it at random, Mr. Maani,
sorry,
because we
Yazan, can you repeat the question?
Yes, a question from Saad Shiha. He said, as an to verify HVOF procedure, knowing that every vendor has his own.
Did you say HD? I don't understand the procedure. What procedure?
HVOF. How do we know that every person has his own?
Yes. I'm so sorry. I'm not able to hear that well. So right, the HVOF procedure that we have is unique and proprietary to ValvTechnologies. It took us over 20 years of experimentation with the robotic HVOF, what we call RITEC, robotically introduced technology. And there's many variables that come into play when you are doing HVOF, the preheating of the valve, the velocity, the temperature, the distance. You want to make sure, I don't know if you can see me or not, that the application for the HVOF is always the same distance and is impacting the ball or the seat perpendicular. So we have numerous movies that we could show you. I would be happy to pull up and to show you an actual application filmed at our HVOF booth. So the application of the HVOF, we have a special methodology of maintaining concentricity on the balls and the seats when they're taken off of the HVOF application, put into the grinding machine, where we maintain 100% concentricity. This gives you what is very important with the TCC coating, tungsten carbide coating, which is uniform thickness around the ball. What you don't want to do is have uneven thickness of the TCC coating, because you'll eventually wear through that TCC coating and be hitting base metal. That's when you would have a failure on the valves. So we're able to produce our valves, maintain concentricity through the application of the HVOF, the application of the tungsten carbide coating, through the grinding process with diamonds, and then we move them into a very proprietary lapping process, which is where we're able to get zero leakage on metal-to-metal seated valves, as you saw in my presentation, with multiple case studies. And we have many more that we'd be happy to talk about and to give as examples.
Okay, let's go with one last question, and then we'll turn to the raffle event that we have. And then we can, if you can give us a link that we can put up in the PowerPoint, so that if anyone has any further questions, you can just go to that, email you guys directly for more clarification.
That would be fine.
Okay, so in the case of TCC, can they be repaired on site, or does it have to be through a regular shop that is by ValvTechnologies? Sorry.
Yes, you know, ordinarily, if you have any issues with the tungsten carbide coatings, it needs to typically to be stripped and then reapplied. You can actually like the base metal, let's just say it was LF2 with a Inconel 625 cladding on it for corrosion resistance. The LF2 gives you a good, stable, strong, high yield base material on the ball and on the seats. Then you can put Inconel 625 on that. We machine that down, and then we apply the HVOF tungsten carbide coating. So when we do repair of valves, if you're in a critical service application, we recommend that for severe service applications, that a maintenance policy where you could have either spare parts in the warehouse, or we would maintain them locally so we could do our repairs very quickly, or that you maintain a standby valve. For what you don't want is for your, say, a scraper trap receiver main isolation valve to go down and to be leaking, and then where you have to take that valve out of line and then wait 2 weeks or longer to have the valve repaired locally. So to have a standby valve in terms of your maintenance and repair philosophy, we highly encourage. And we have many different methods where we go through and we can look through the P&ID drawings and work together to identify the high critical service valves that, if they go down, can shut in a major portion of your production. So it's very important that you have very good maintenance and operation procedures and repair procedures so that you can quickly turn these valves around. There's different philosophies on that around the world by end users. And oftentimes valves are graded. You can have A, B, C, D, D being your more commodity valves, A being your very severe service valves. Or you could have 1, 2, 3, 4, 5 Many end users around the world utilize this type of a classification so that they can easily identify on the P&ID drawings which valves can be problematic. And I have no doubt that in Kingdom right now, many of the users who are interacting and responsible for the production of oil and gas, they know already where their headaches are and the valves that are failing. What we would really appreciate and would look forward to would be able to work together and collaborate on any type of field failures or severe service valves that you're currently having issues with on the production side, on the midstream side, or on the hydrocarbon refining side or chemical plants downstream. We service many different industries. And we would be happy to put valves on test so that we could prove to you that our valves work, very similar to the one that we already have done in Kingdom with the 30-inch, 300-pound class receiver valve.
All right. I think this marks the end of the technical part. Once again, I'd like to thank John, David, Yazan, thank you very much for hosting this event, and thank you very much for sharing your knowledge with us this evening.
Thank you. It was my pleasure.
Thank you.
All right.